Alright, ladies and gentlemen, we're on to our last help video for 8-26. This help video will focus on our last equation, numbers 14 through 17. In our last equation, we have aqueous silver nitrate. Silver is Ag, nitrate's NO3. They're both 1 minus, crisscross. And it's going to react with aluminum chloride. Aluminum's Al, chloride's Cl. Cl's 1 minus, aluminum's 3 plus, crisscross. Now, we have to look to see what's going to happen in this reaction, if anything. Well, this is quite possibly going to be a double displacement reaction because we have aqueous solutions of both of these. This one has silver ions floating around, and this one has nitrate ions floating around. And we pour it together with this aqueous solution. This has Al3 pluses floating around along with Cl minuses. So what happens when the Ag1 pluses bump into the Cl1 minuses? We come up here on our solubility chart. Here's silver. We can move on down to the chloride, and we see that silver chloride is I insoluble. They will pull together, and water will not be able to keep them pulled apart. They'll precipitate out of solution. What happens when the aluminums bump into the nitrates? We come up here on our chart. Here's aluminum. We head on down to the nitrates. There's the nitrates. There's the aluminum. It is S soluble, so they'll stay floating around in solution. The AlNO3s will remain aqueous. However, one of our conditions have been met. We have formed a solid precipitate. The silver, first thing there, bumps into the chloride, second thing there, and they precipitate out of solution. The Als bump into the NO3s. They're fine. They stay aqueous. They'll remain in solution. When we go to balance this thing, we have 3 chlorines there, so we would need a 3 in front. If we have a 3 in front there, we would need a 3 in front here, so that we have 3 silvers. The 3 in front here gives us 3 nitrates, which is what we have on that side, 3 nitrates. Al's 3 plus, nitrates 1 minus, crisscross. There would have to be a 3 there. Second thing they want us to do is write this in ionic form. Ionic form, as you remember, means if it's aqueous, we pull it apart into its ions. So we pull apart the silver and the nitrate into its ions. We have 3 silvers ions floating around for every 3 nitrates floating around. We also have to pull apart this as well. How do we pull apart the AlCl3s? Well, the Al3 pluses will be floating around, and the 3 Cl minuses will be floating around. That's the reactant side written in ionic form. What about the product side? Well, this is aqueous right over here. So we have to pull that apart. We'll have an Al3 plus floating around. We'll have 3 NO3 minuses floating around. We will not pull apart the AgCls, though. They precipitated out of solution. They are not ions freely floating around. Ionic equation says show the ions that are freely floating apart. The next thing they want us to do is write the net ionic equation. The net ionic equation. The net ionic equation, net means show only the ones that changed. In other words, if it is the same on the reactant side as it is on the product side, we don't show it. It hasn't changed. If we look on this side, we have 3 NO3 minuses floating around, and we have an Al3 plus floating around. Same thing is on that side. 3 NO3 minuses floating around, 3 Al3 pluses floating around. We're not going to show that in the net ionic. The net ionic wants only the things that are changing. Take a look here. We have 3 Cl minuses floating around. We have 3 Ag pluses floating around. Over here, they're not floating around. They've joined together and precipitated out of solution. So when we're looking for the net, those were the ones that weren't the same on both sides. So we would write 3 Ag pluses 3 Cl minuses on the reactant side. The product side, we would write what it changed into, a solid precipitate, 3AgCl. Then they want us to write the spectator ions. The spectator ions, the word spectator means you're watching, you're not participating, you're just a spectator. They want us to write who didn't change. There's the 3 NO3 minuses and the Al3 plus. Same thing on this side, 3 NO3 minuses and the Al3 plus. They didn't change. They were the spectators, so we write them as our spectator ions. If you have any questions over anything that was discussed in any of the 3 help videos, don't hesitate to email that question to me. Thank you for watching.